Hello and welcome. Today, we are going to break down one of the most fundamental concepts in organic chemistry, deprotonation. Understanding this simple process is key to unlocking countless reaction mechanisms. So, what exactly is deprotonation? At its core, deprotonation is the removal of a proton from a molecule. In organic chemistry, a proton is simply a hydrogen ion, written as H+. This process doesn't just happen on its own, it requires another chemical species to do the work. This species is called a base. A base is a molecule or ion that has a lone pair of electrons it can use to grab the proton. So, you have an acid, which is the molecule that loses the proton, and a base, which is the molecule that takes the proton. When the base removes the proton from the acid, two new things are formed. The original acid, now missing its proton and having an extra pair of electrons, becomes what we call the conjugate base. The original base, having accepted the proton, becomes the conjugate acid. For example, if a strong base like the amide ion, NH2, reacts with water, H2O, the amide ion will pull a proton off the water molecule. The water becomes its conjugate base, the hydroxide ion, OH, and the amide ion becomes its conjugate acid, ammonia, NH3. This leads to the most important question: why do we care about deprotonation? We care because it is often the first and most critical step in a chemical reaction. Deprotonation can transform a relatively unreactive molecule into a highly reactive one. It often creates an anion, a negatively charged species. These anions are frequently powerful nucleophiles, meaning they are excellent at attacking electron-deficient centers to form new chemical bonds. A classic example is deprotonating an alcohol to form an alkoxide. An alcohol is a weak nucleophile, but once a base removes its acidic proton, it becomes a negatively charged alkoxide, which is a much stronger nucleophile. This newly formed alkoxide can then participate in important reactions like the Williamson ether synthesis. The success of a deprotonation reaction depends heavily on acidity, which we measure using pKa. A lower pKa value means a molecule is more acidic and its proton is easier to remove. To deprotonate a specific acid, you must use a base that is strong enough for the job. The general rule is that the conjugate acid of the base you use must have a higher pKa than the acid you are trying to deprotonate. This ensures the reaction is favorable. So, to recap, deprotonation is the removal of a proton by a base. It creates a conjugate base and a conjugate acid, and it's a vital step for generating reactive nucleophiles for synthesis. Thank you so much for watching. I hope this explanation made the concept of deprotonation clearer for you. If you found this video helpful, please show your support by liking the video, leaving a comment with any questions, and subscribing to the channel for more chemistry content. Your support makes these videos possible. See you in the next one.